Assalamualaikum and a very good day. I wish to all lecturer. My name is Muhamad Azrul Hafiz bin Muhammad Jamil under supervision of Prof IR Dr. Muhammad Wazir bin Mustafa. So today I will be presenting my final year project with the title of Mitigation of Voltage Sag under Contingency in Distribution System by using D-STATCOM. Voltage sag is described as the reduction of RMS voltage in the range of 10 to 90% of nominal voltage for the duration of 0.5 cycles to 1 minute. The simulation is being simulated by using MATLAB Simulink 2019A. The test system had been designed based on the distribution system in Malaysia. The left hand side of the circuit will be represented as a main intake substation. Here, the transformer will step down the voltage from 132 kV to 11 kV. While for the right hand side, it will represent as a distribution substation. Here, the transformer will step down from 11 kV to 400 volt. The transformer that has been used, the three customer will represented as a series RLC load. There are three type of fault that has been considered in the simulation, which is three phase fault, single line to ground fault, and double line to ground fault. Fault resistance used is 0.66 ohm for all the cases and has been created to occur for 0.2 second, which is from 0.4 to 0.6 second. So here I run the simulation for the three phase fault. So load side due to three phase fault are shown in the scope. Here it can be seen that all three phases had experienced voltage sag from 0.4 to 0.6 second. For the second case, which is double line to ground fault, phase A and phase B has been chosen to occur voltage sag. As can be seen from the voltage waveform at the load side, there is a voltage sag occur at phase A and phase B, while no voltage sag occur at phase C. For the third cases, which is single line to ground fault, phase A had been chosen to occur fault. As can be seen from the voltage waveform at the load side, there's a voltage sag occur for phase A due to single line to ground fault, and there's no at phase B and phase C. The objective of this project is to mitigate voltage sag due to occurrence of fault by using D-STATCOM. As can be seen here, D-STATCOM are connected parallelly to the system through the injection transformer. D-STATCOM consists of controller, voltage source converter, energy storage circuit, and also injection transformer. Three-phase circuit breaker is being used for the isolation purpose. First, the discharged voltage at the load side are measured and will be passed to the controller. PI controller has the responsibility to drive the error signal to zero. The error signal is the difference between the distorted voltage and the reference voltage. PI controller will pass the signal to the phase modulator. Here, the signal received from PI controller will be summed up with the balanced phase angle supply voltage at 120 degree. Then it will be passed to PWM generator. In PWM generator, the voltage received from the phase modulator are been compared with the triangular carrier signal. PWM generator will generate the switching pulse for the voltage source converter. For the voltage source converter, two level with 3 arm IGBT is being used for the switching device. The voltage source converter will receive the energy from the energy storage circuit. The energy storage circuit consists of DC capacitor, resistor, and also DC source. Voltage source converter will convert DC voltage to AC voltage and inject the voltage to the injection transformer. For the injection transformer lumped together with the main intake substation transformer, and three-phase winding transformer is being used. Here, I run the simulation for the first case, which is three-phase fault occur at the system. From the scope at the customer side, it can be seen that voltage profile is being improved by D-STATCOM closer to the nominal voltage even when fault occur. The small amount of voltage sag is under 10%, which is still acceptable. Next, I will run the simulation for the second case, which is double line to ground fault. Phase A and phase B has been chosen to occur fault. From the scope at the load side, it can be seen that voltage profile has been improved by D-STATCOM closer to the nominal voltage when double line to ground fault occur. Finally, I run the third case, which is single line to ground fault, and phase A has been chosen to occur fault. From the scope, it can be seen that D-STATCOM able to reduce magnitude of voltage sag perfectly close to the nominal voltage when single line to ground fault occur. In this project, DVR has been constructed in order to validate the performance of D-STATCOM. The main difference between DVR and D-STATCOM is DVR is connected in series with the system, while D-STATCOM is connected in parallel with the system. DVR consists of controller, voltage source converter, energy storage circuit, LC filter, and also injection transformer. When voltage sag occur, the controller of DVR will receive the signal in terms of the distorted voltage. The controller will process the error signal, which is the difference between the distorted voltage and the reference voltage, to 0, and then the signal will be passed to the PWM generator. In PWM generator, the signal will be compared with the triangular carrier signal to generate the switching pulse for voltage source converter. Voltage source converter consists of 2 level with 3 arm IGBT, same as been used in the STATCOM. Voltage source converter will receive the from the energy storage circuit, which consists of DC capacitor, resistor, and DC supply. LC filter is being used to eliminate the harmonic distortion caused by the switching of the voltage source converter. Finally, the voltage will be injected to the system through the injection transformer. So here I run the simulation of DVR for the first case, which is the occurrence of 3-phase fault at the system. From the scope of the load side, it can be seen that the voltage sag that occur between 0.4 to 0.6 has been improved by the DVR. The small magnitude of voltage sag is below than 10%, which is still acceptable. Next, I will run the simulation for the second case, which is the occurrence of double line to ground fault. Phase A and phase B has been chosen to occur fault. From the scope of the load side, it can be seen that voltage sag occurrence between 0.4 to 0.6 has been improved by the DVR. Finally, I will run the third cases, which is the occurrence of single line to ground fault. Phase A has been chosen to occur fault. From the scope at the load side, it can be seen that the voltage sag magnitude has been improved close to the nominal voltage, even when single line to ground fault occur.